Today we are playing around with the differences of 2. We are playing around some more with prime numbers. We are throwing darts at a dartboard. And then we are playing around with square matrix multiplication. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more challenging katas later in the episode. Today's episode will be themed around loops, and we start today's warm-up segment with a function that takes an array of words and smashes them together into a sentence and returns that sentence. There is no need to sanitize or add punctuation to the words, but there should be a space in between each word. Let's go ahead and give this a try here. Const smash, and we have our array of words as our lone argument here. And what we can do with those words is we can use the array object's join method, whereas you can use the array object's split method to split a string using a common separator like a space or a blank string. You can use the array object's join method to join an array of substrings or numbers together using a separator character or a blank string. We will do just that here. We'll do words, not join, and in this particular case we will be using a blank space as the separator character. In other words, the words in this array will be joined together into a string, and there will be a blank space in between each word. Alright, let's go ahead and punch this into Codewars and see what this looks like. And we are good on that. Our next warm-up kata, we are given a string, and our goal is to return a string in which each character, case sensitive, is repeated once. Let's go ahead and give this one a go here. I'm going to hit train here. Our function signature will be const double char, and we will have our string as the lone parameter here. And what we will do with each character in the string is, let me show you another way of splitting a string into its individual characters, in addition to the string.split method, And this will involve destructuring and the spread syntax here. What we'll do is, in between these brackets, we'll do ... str. And in so doing, this little bit of code will split our string into its individual characters using a blank string separator, just like what we do with the string.split method. Now, what we'll do with this resulting array, we're going to run it through the reduce method. And we will have our accumulator and our character here. And what this will do, we will concatenate to our accumulator string the current character repeated twice. And we will start our accumulator with a blank string. Now, I went through the string object's repeat method in past episodes of this, but let me reiterate. The string object's repeat method takes one argument, which is a number that tells the method how many times that string or character should be repeated. In this case, we are repeating it twice. Alright, let's go ahead and test this out here. Let me pull this string out of here. We're going to do a console.log, double char, and we are going to pass in that string right here. Alright, let's go ahead and test this out here. Node, warm-up, double char. And as you can see, we have our return string with each of the characters repeated exactly once. Alright, let's go ahead and punch this into Codewars and see what this looks like. We're going to put this in here, and we are going to hit attempt. And we are good on that. For our next warm-up kata, we are given an integer. And the goal of this kata is to return a string representing a shape that is as long and as wide as that integer, a square. And the integer will be a whole number between 1 and 50. For example, given an integer 3, this should be the expected return value. I call your attention to this diagram in the Kata instructions here. Alright, let's go ahead and give this a try here. Alright, we are going to do const generate shape. We're going to pass in our integer here. And what we'll do in here, actually, what we'll go ahead and do in here is, now, yep, there will be new lines in here. So, what we will do is, we will go ahead and try this. Alright, we don't have any arrays to work with in our parameters here. So what we'll need to go ahead and do, we'll need to go ahead and generate a new array. We're going to create a new array here with the number that we pass in here as the number of elements here. And this is going to be what's returned. And wait, I have an idea. What we'll do here, we'll do new array, pass in the number of elements in that array, which will be the integer that we pass in, and we will fill each one with our plus sign here, which will represent each character in our square, repeated the number of times that we pass in here. And then we'll take that resulting array and we will join all of the elements together, all those strings together with a new line character. Alright, let's go ahead and test this out here. We're going to do a console.log, and we are going to do generate shape. We're going to pass in 3 here. Let's test this out here. Node warmup build square. And generate shape is not defined because I misspelled generate. And as you can see, we have our square right here. Alright, let's go ahead and punch this into Codewars and see what this looks like here. I'm going to hit copy. Paste this into our solution here. We're going to run the tests. And we are good on that. For our 4th warm-up kata, we have come to the public service announcement segment of our warm-up section here. We are given a sentence representing the number of alcoholic beverages we imbibed last night. And the goal of this kata is for each one alcoholic beverage we drink, we are to return a string suggesting how many glasses of water we should drink. Let me go ahead and read the kata instructions here. Codewars Bar recommends you drink 1 glass of water per standard drink so you are not hung over tomorrow morning. Your fellow coders have brought you several drinks tonight in the form of a string. The goal of this kata is to return a string suggesting how many glasses of water you should drink to not be hung over. Note, to keep things simple, we will consider that any numbered thing in the string is a drink. I can understand that. There's basically a cocktail for every... Well, use your imagination. Anyway, what we'll do here... let's go ahead and get started with this. We're going to do const hydrate. We're going to do our alcohol string, we'll call it. And what we'll do with that is we're going to go ahead and take that string. We'll create an array called items. We're going to take that string and we are going to split that into its individual strings using a comma and a space for the separator string. And what we're going to do, we're going to get the quantities of that, and we're going to do items.map. We're going to run the items array through the map method here. We're going to take our item here, and what I think we're going to try doing here is we want to get to the number at the start of this here. So I imagine we will be going from this to the first space. So what we'll go ahead and do is we're going to go ahead and get the index of the first space. On space index, we're going to set that equal to item.index of the space. And then we will go ahead and get the quantity string, and we were going to go ahead and do item.substring, and this is going to, we're going to start it at 0, and we're going to go up to space index, I think. And then what we're going to do from here, we're going to run that through parse int. And we're going to go ahead and pass in that quantity string right here. And this actually should be spelled hydrate. All right, let's go ahead and console.log that and see what that looks like. Actually, we're going to go ahead and just return the string itself, just to make sure we have that space index correct here, this substring call here correct. I'm going to go ahead and take this string here. I'm going to go ahead and do a console.log down here, hydrate, and we're going to pass that string in right here. Let's go ahead and test this out. Warm up and drink responsibly. Hydrate is not defined. I misspelled hydrate again. Let's try that again. And we have our array of strings, 15211, and we do have that substring call correct here. So what we're going to go ahead and do, we're going to run the parse int method, and we are going to pass in this quantity string right here. And that should give us the numbers 1521 and 1. All right, with that being said, let's go ahead and continue on with this here. We're going to do const water count, and we're going to use the reduce method on the quantities array to add together the numbers in that array. And we're going to do just acc plus val, and the initial accumulator is 0. And we are going to return a string here that says, a template string that says water count glasses of water. And that should give us 10 glasses of water here. All right, let's go ahead and punch this into Codewars and see what this looks like here. We're gonna run the tests, and something is going wrong here. Oh, right. Okay. We're gonna replace glasses here with another placeholder here. Water count is equal to 1, then we just say glass. Otherwise do glasses. All right, let's go ahead and punch that into Codewars here and see what that looks like. Run the tests, and we are still going wrong here. Expected 2 glasses of water to equal 3. Okay. All right, let's go ahead and console.log that alcohol string here. See where we're going wrong. Alcohol string. 1 beer, 2 glasses of wine, and 1 shot. Oh, wait a minute. Ooh. Yeah, okay, we also need to account for and as well. Okay, I think we will need to use a regular expression then for this. Okay, what we'll go ahead and do, we're going to go ahead and change this to and here. Yeah, I forgot to account for that in the Kata instructions here. Alright, I think we'll try using a regular expression. The split method, if I'm not mistaken, can also accept regular expressions. So what we'll go ahead and do, we'll try this here. We'll have a regular expression that takes either comma and a space, or the word and here. Let's try that. NaN glasses of water. Let's go ahead and console.log that here. Yeah, we do not want that here. Maybe it's capital S here. Okay, let's go back to that comma space here. 1 glass of wine and 1 beer. And what we'll go ahead and... Alright, have an idea. Okay, what we'll go ahead and do here. Oh. Try that and here. One beer, 1 shot, 1 glass of wine, 1 beer. Yeah, I think we got it now. But now we need to go ahead and trim our substrings here. And what we'll go ahead and do is we can go ahead and do that here. Okay, what we'll go ahead and do, item equals item dot trim in the predicate function of our map method. And yeah, that's not working either. Okay. Maybe try a capture group here. We'll try the space, try the comma and space here first. And we'll go ahead and console.log our items array here. Okay. Maybe it's the lowercase s then. Yeah, I still occasionally struggle at this, unfortunately. Maybe. Okay, let's go back to the common space here. You know what? I will be right back. Give me a moment. Okay, I'm back. So what I needed to do in our regular expression here, we needed to do a comma and then the white space character class here, or the word and. And what I was doing wrong here, I was including the global flag in our regular expression here. Let's try putting that back in here. And that would give us Actually, that does work too. We do have our 1 shot, 5 beers, 2 shots, 1 glass of wine, and 1 beer. Now, making this change would result in one of our strings having some trailing white space in front of it here. So what I did here, I took each of our items and trimmed the white space out of it with the trim method here in our map method's predicate function. Alright, this should be right now. Let's go ahead and get rid of this console.log. I'm going to go ahead and punch this into Codewars and see what this looks like. Whoops. Alright, let's go ahead and punch this in here. Now we'll run the tests. And we are good on that. My goodness, that was a doozy that did not need to be. Anyway, finally, our last warm-up kata here. We are taking on an alphabet war here. Let me read the kata instructions here. There is a war and nobody knows, the alphabet war. There are two groups of hostile letters. The tension between the left side letters and the right side letters was too high, and the war began. The goal of this kata is to write a function that accepts a string consisting of only lowercase letters and returns whoever wins the fight. When the left side wins, the string return says left side wins. When the right side wins, the string return will say right side wins. In other cases, we return a string that says let's fight again. I'll call your attention to these two diagrams in the kata instructions here. The left side letters have the following power values. W is 4, P is 3, B is 2, S is 1. And the right side letters have the following power values here. M is 4, Q is 3, D is 2, and Z is 1. Now, this is some examples here as to what should be returned from this kata solution here. Alright, let's go ahead and give this one a try here. We're going to do const alpha bet war. We're going to have our fight string, as the kata instructions call it. And what we're going to go ahead and do is we are going to iterate over the... We're going to go ahead and iterate over this string's characters here. We're going to keep track of a result here. And we're going to set that equal to 0. And what we'll go ahead and do that result, we can actually go ahead and run this string through the reduce method here. And what we'll go ahead and do, we're going to do const outcome. We're going to set that equal to, we're going to go ahead and do the spread syntax again with our string here to get the individual characters out of it here. And we're going to run that through the reduce method. We're going to have our accumulator, and we're going to have our char right here. And we're going to set the initial accumulator to 0. And what we're going to go ahead and do is, we're going to do a little bit of a switch statement in here. We're going to check this, see what our character is here. And we're going to go ahead and do it like this. We're going to do case W. Case W has a power of 4 towards the left side, so we're going to go ahead and do return ec minus 4. We're going to do case P. We're going to do return ec minus 3. Case B, we're going to do return ec minus 2. And case S, we're going to return, we're going to return ec minus 1. Now, for the right side letters, we're going to go ahead and add to our accumulator here. We're going to do case M. We're going to return ec plus 4. Case Q, we're going to return ec plus 3. We're going to do case D, and we're going to go ahead and return ec plus 2. And finally, we're going to do case Z, and we're going to return ec plus 1. Now, any other character, we're going to return our accumulator, and without any changes made to it. All right, what we'll go ahead and do here, we're going to take this outcome, we're going to check to see if it's greater than or less than 0. If outcome is less than 0, then we're going to return the string left side wins. All right, we're going to do else if. If the outcome is greater than 0, we return right side wins. And then finally, if the outcome is 0, we're going to return let's fight again. All right, we're going to go ahead and punch this into Codewars to see what this looks like here. We're going to go ahead and run the tests. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. Now, before we move on to our next kata here, I want to show you a better way of implementing the solution to the responsible drinking warm-up kata here. This, what you see here and what you saw during our fourth kata of our warm-up segment, is what happens when you overthink things here. I want to show you a better way to implement this that doesn't involve all of this here. So I'm going to go ahead and get rid of all of this here, and we're going to go ahead and do our quantities count here. Const quantities. And what we're going to go ahead and do here, we're going to go ahead and take our alcohol string, and we are going to split that into its individual words. We're going to run that through the filter method. And we're going to, in our predicate function, we're going to have a word here, and we are going to return true if exclamation point is nan. We're going to pass in our word right here. Now, what this does here, this is the isNan function. And according to this, it returns a Boolean value that indicates whether the given value is the reserved value NaN or not a number. Now, there are two versions of this function here. The global namespace version of this function, which we're using here, and a separate version of this method in the number object. Now, we're using the global version here, and this can take any input here, including a string, and this will return true if that string can be parsed into a, or rather false, if this string can be parsed into a number. So, what we go ahead and do, we take our alcohol string that we passed in here, we split it into its individual words with the blank string separator, and then we run that resulting array through the filter method. And its predicate function, we have our word right here passed in, and we return true if that word parsed into a number does not resolve to the reserved keyword NaN, or not a number. In other words, this returns false. Now, we're going to take that resulting array, actually, and we're going to run that through the map method. And we're going to go ahead and take that number, and we're going to run that through the parseInt method. Now, if I'm right, we should get the same result here. And we will go ahead and test that out here. Node warmup drink responsibly, and we should get our same response, 10 glasses of water. So I'm going to go ahead and hit train again here. And we're going to go ahead and punch this into Codewars and see what this looks like. We're going to hit test. And we are good. This is a much better solution than what you saw before. Now, on to our next kata. Given an array of integers, the goal of this kata is to return an array of pairs of the integers in the array such that the difference between the two integers in each pair is 2. Let me call your attention to the examples in this kata solution here. Here we have the array 1, 2, 3, 4. If implemented correctly, this kata solution should return the array of pairs 1 and 3 and 2 and 4, because the difference between the integers in each pair is 2. Now, let me call your attention to this one here, the array 1, 23, 3, 4, and 7. Now, this array only returns one pair, 1 and 3, because those are the only two integers in this array, such that the difference between the two integers is 2. Now, this array here, 4, 3, 1, 5, 6, returns the pairs 1 and 3, 3 and 5, and 4 and 6. Now, it doesn't necessarily matter if one integer in this array is used more than once, just as long as there is another integer in the array such that the difference between the two integers in that pair that would result is 2. Alright, let's go ahead and give this a shot here. Alright, we're going to go ahead and iterate over the numbers in our numbers array here. We're going to go ahead and keep track of a result here. And that is going to be what's returned here. Now we're going to do for const, I think, number of numbers. And what we'll go ahead and do in here, we're going to go ahead and take this number, add 2 to it, and then look for the index of that resulting sum in our numbers array here. And what we'll go ahead and do, we're going to do const other number, and we're going to do number plus 2, and we're going to go ahead and do const other number index. We're going to set that to numbers.index of other number. And now if the other number index is equal to -1, that means that other number is not present in the numbers array. Actually, we're going to go ahead and do if other number index is not -1. Yeah, I think that's what we'll go ahead and do. We're going to go ahead and return a pair, push a pair into our result array, and that pair is going to consist of our number and the other number right here. And by the end of this for loop, we should have our array of pairs here. All right, let's go ahead and test this out here. Let's take this array here, and we're going to do a console.log 2's difference. We're going to pass this array in. We're going to go ahead and do node difference of 2, and we should get the pair 1 and 3, and that is what we want to see. All right, we're going to go ahead and try this array here. 4, 3, 1, 5, and 6. And we get to the pairs 1, 3, 3, and 5, 4, and 6. But I don't think not necessarily in the order we want. Not necessarily in the order we wanted it, I think. Let's punch this into Codewars and see if this gives us any problems here. Let's go ahead and run the tests. These tests pass. Let's hit attempt. And there are no problems here. We are good. Now, according to the Kata instructions, the order of the integers in the input array does not matter. However, based on the examples I saw in the Kata instructions, I was under the assumption that the pairs of integers had to be sorted in ascending order. As it turns out, the ordering of the pairs actually doesn't matter, just as long as the integers in each pair are in ascending order. Like you have the integer first and then the integer plus 2 second. Recall in a past episode of Versus Codewars, we went over the factorial of a number, in which we take all of the natural integers leading up to that number and multiply them together. Here, we are going over what is called the primorial of a number. The primorial of a number is similar to a factorial of a number. The difference here is that instead of all of the natural integers being multiplied, only prime numbers are multiplied here. Given an integer n, the goal of this kata is to return its primorial by multiplying together the first n terms of the prime number sequence. Alright, let's go ahead and give this a try here. Alright, we are going to need the help of a helper function here. And we're going to go ahead and call that isPrime. And we're going to go ahead and pass a number into that. And what we're going to go ahead and do with that, we're going to go ahead and if num is less than or equal to 1, we return false. If num is equal to 2, num is equal to 2, we return true. And then we'll do our for loop here. Recall the next prime number warm-up kata we did in the past here. For let I equals 0, I times I is less than or equal to num, and then plus plus I. If num modulo I is equal to 0, then we return false. And then we return true if we reach the end of this for loop. That way we know that the number given is prime. We are going to need that here. So what we're going to go ahead and do, we're going to keep track of a results array, or a primes array, rather. We're going to set that equal to an empty array. And while primes.length is less than n, what we passed in for n, we're going to go ahead and do... Actually, this might be better suited as a for loop here. For let I equals 2, primes.length is, continue this for loop while as long as primes.length is less than 5, plus plus I. And what we'll go ahead and do here, if is prime, and we pass in our I here, and if this evaluates to true, we'll go ahead and do primes.push. We're going to push in our I here. And finally, we'll go ahead and take that resulting array. We'll do primes.reduce. We'll have our accumulator and our value. We're going to do ec times value. And we're going to set the initial accumulator to 1. All right, let's explain what's going on here. We have our num primorial function here. It takes a single integer n. This is the number of terms in the prime number sequence we want to multiply together. We begin here with a helper function that checks to see if a given number is prime. Recall during the next prime kata that we did during one of the warm-up segments on a past episode of Versus Codewars. We were to write this function to determine if the given number was prime. And we do that right here. We do if num is less than or equal to 1, we return false. Because 1 has only one number by which it is divisible. Prime numbers require exactly 2 numbers by which it is divisible, 1 and itself. Now, 2 being the only even prime number here, if this number passed in is set to 2, we return true. And then we go into this for loop here. We start at I equals 0, and we continue as long as I squared is less than or equal to our num here, and then we increment by 1 each iteration here. And we return false here if num modulo I, the remainder of num divided by I, is equal to 0 here. Because if that is true, then we know that I is divisible by num, so this is not a prime number here. We return false. If we reach the end of this for loop here, we go ahead and return true because now we know this is a prime number. Now, with that helper function implemented, we set up this primes array right here, and we go into another for loop here. We start I at 2 here, and we continue as long as the length of the primes array is less than 5, and we step by 1 each iteration here. Whenever this helper function with this index passed in resolves to true, we go ahead and push our prime number into our primes array. Alright, now what we'll go ahead and do, we'll take that resulting array and we'll run that through the reduce method. We start with an initial accumulator at 1, and each predicate function call, we take that accumulator and multiply it by the value. And as a result, we should have the primorial of n. Let's go ahead and test this out here. We're going to do a console.log num primorial. We're going to pass in 3 here. Let's test this out here. Node primorial. And I regret to inform you we have an infinite loop on our hands here. Why do we have an infinite loop? All right, let's go ahead and console.log our primes. Okay, I might have to reimagine this loop here. I have another idea. We'll do let index equal 2, and we're going to do a while loop here instead. While primes.length is less than 5, we're going to go ahead and do if is prime. We're going to pass in our index, and then we're going to go ahead and do index plus plus. We're going to use the postscript incrementation operator here. So when this function is done with our index here, this is going to increment it by 1. Anyway, if our is prime, or rather, that might not be the best idea because we need that index. We're going to set that equal to true. We're going to check to see if is prime with this index evaluates to true. If it does, we're going to go ahead and do primes.push. We're going to push our index in right here. And we're going to go ahead and do index plus plus at the end of our while loop here. Let's try that again. Oh, wait a minute. N, not 5. Mistyped there. Let's try that again. Now we get 30. Let's try passing in 5 here. We get 2310. Let's try 6 here. And we get 30,030. Now let's have a look at some of the tests down here. Let's try passing in 9. That was pretty quick. Let's try 90. 9,000. Okay, let's go ahead and punch this into Codewars and see what this looks like here. Alright, we're going to go ahead and run our tests here. And we are good. Now, I don't have that much to say about the Kata solution itself, but I have a couple of takeaways I would like you to glean from this Kata solution. First, whenever you are using the array objects to reduce method to multiply together the numbers in an array, be sure you set the initial accumulator to 1 instead of 0. Otherwise, you are going to have problems with the numbers in the array being multiplied by 0, and you're going to get 0 as the return, and you might not want that. Second of all, whereas factorials are mathematically written as n exclamation point, where n would be the number up to which you want to multiply the values of the sequence, primorials are written as follows: capital P subscript n pound sign, where n is the term of the prime number sequence you want to multiply the prime numbers up to. For example, if you had the number 3, you would multiply together the prime numbers 2, 3, and 5. 2 times 3 is 6, and then 6 times 5 would be 30. As such, 30 would be the primorial of the term 3. For this kata, we are sticking with the theme of prime numbers here. Given an array of integers, the goal of this kata is to calculate the minimum integer that should be pushed into that array, such that the sum of the original array plus that minimum integer is equal to the next nearest term in the prime number sequence. Let's go ahead and give this a try here. As you can see, I brought back our isPrime helper function from the previous kata here. This is going to come in handy here. Alright, we will need the help of another helper function here, and we're going to call this const get next nearest prime. And we're going to pass in an integer here. And what we will do here is we're going to go ahead and start with that integer for y. We're going to do a while true loop here, and we're going to go ahead and do if isPrime integer is equal to true, and then we go ahead and then we go ahead and actually we're going to go ahead and set up an index here. Let index equal integer, while isPrime index is equal to true. If isPrime index is equal to true, we return index. And then we do index plus right here. Alright, so what this helper function does here, we keep track of an index here, which we initially set to the integer that we pass in here. And then in an infinite while loop here, we check to see if the current index is a prime number. If it's true, we break out of this loop and return that index. Otherwise, we go ahead and increment the index and continue with the while loop here. Alright, what we will go ahead and do from here, we have our integers right here, and what we need to do, we need to calculate the sum of those integers here. And we can simply do that by doing this. Const sum equals, const sum equals integers.reduce. We'll have our accumulator and value here, acc plus val, and our initial accumulator set to 0. This simply calculates the sum of the elements in our integers array here. Now, what we need to do, we need to get the next nearest prime number to that. So what we'll do here, we'll do const next prime equals get next nearest prime, and we will pass in our sum here. And the goal of this kata is to return the minimum integer that needs to be pushed into this array, such that the resulting sum of the resulting array will be equal to the next nearest prime number. We should have that here, so we'll do next prime, we'll return next prime minus sum. Alright, let's go ahead and test this out here. How about console.log transform, what was that function called again? Minimum number. We'll pass in 3, 1, 2. For the return, I expect to see 1, because the sum of the numbers in this array is 6, and the next prime number after that is 7. 7 minus 6 equals 1, so I expect this to return 1. Let's test this out here. Node transform to prime, and we do see 1 returned. Let's try another array here. 2, 12, 8, 4, and 6. Now, the sum of the elements in this array, 2, 14, 22, 26, 32. The sum of the elements in this array is 32. The next prime number after that, I believe, is 37. Yeah, the Kata instruction says 37 is the next prime number after that. So I expect to see 5 returned here. Let's have a look. And we do in fact see 5 returned here. How about this one? We have the elements 50, 39, 49, 6, 17, and 28. Now, the sum of these elements is 189. The next prime number after that is 191, so I expect to see 2 returned here. And we do. Alright, I think we're ready to punch this into Codewars to see what this looks like. We're going to go ahead and copy this and paste this down here. Run the tests. Uh-oh. Looks like we have an error here. Minimum number has already been declared. Oh, that would be why. Yeah, let's try that again here. Run the tests. And we are good. Now, I don't have anything to say about this Kata solution here, so before I move on to the next Kata, I would like to plug something to you guys here. I am a web developer. I specialize in front-end web development, particularly with React.js. I'm also working on Next.js too. But I sometimes also do back-end web development, particularly with Node.js and Express.js, using MongoDB and Mongoose for database drivers. If you have any ideas for a web application you would like to see me write, feel free to drop suggestions in the comments section below. I'm always looking for good ideas for good web applications, and I would like to hear them. So remember that Codewars bar where we learned about responsible drinking and glasses of water during the warm-up segment today? That very same Codewars bar has recently hired us to calculate scores for a dartboard game. Given an array of numbers representing the radii of darts thrown onto a dartboard, each one relative to that dartboard's center, the goal of this kata is to calculate a total score based on those radii as follows. There is no score, 0 points for any radii above 10. You score 5 points if you throw the dart at a radii inclusively between 5 and 10. You score 10 points if you throw the dart at a radii below 5. And if all of the darts you throw land at a radii below 5, you gain an additional 100 bonus points. Let's go ahead and give this a try here. What I think we will go ahead and do is, first we need to handle the edge case of an empty array. If radii.length is equal to 0, then we just go ahead and return 0 here. Now, what we will go ahead and do is, we'll go ahead and calculate our score here. Score equals radii, and we will use the reduce method here. We will have our accumulator and our radius here. Or rather, I think we'll call our accumulator here points, and then we will have our radius here. And we'll set our initial accumulator to 0. What we will go ahead and do, first, if our radius is above 10, greater than 10, we just return our accumulator here. Whoops, I said, yeah, points actually. Yeah, so used to calling our accumulator acc. Anyway, else if our radius is greater than or equal to 5 and our radius is less than or equal to 10. I think that's it. Yeah, if our radius is greater than or equal to 5 and less than or equal to 10, we will go ahead and do return points plus 5. What points plus 5. And then else if our radius is less than 5, we will do points plus 10. And that should get us our initial score right here. Now, there's one easy way to determine if all of our darts landed up below 5, and that would be to check to see if our points here resulting from this reduce call here is equal to the length of our radii array times 10. So, if we had thrown all of our darts below a radius of 5, and we had 5 darts to throw, our score here should be 50, because we have 5 darts, 5 times 10 is 50. So, what we will go ahead and do is, we will return, if our radii.length times 10 is equal to our score, we will return score plus 100. Otherwise, we will return our score. Alright, let's go ahead and test it. Let's go ahead and explain what is going on here. We have our score throws Kata function here. We take our radii array as its lone argument. That is the radii of the darts that we threw at the dartboard here. We handle the edge case of returning 0 if there were no darts thrown. We have our score here, and we set that to the return of the reduce call here. In the predicate function, we keep track of our points, which we initially set to 0, and the radius of each dart relative to the center of the dartboard here. If that radius is greater than 10, we score no points here, so we just return the value of the points accumulator here. If that radius is greater than or equal to 5 and less than or equal to 10, we return the points accumulator plus 5 because we just scored 5 points here. Otherwise, if our radius is less than 5, then we scored 10 points. We return our points accumulator plus 10. Now, we check to see if our score is equal to the length of our radii array times 10. If it is, that tells us that all of our darts landed with a radius of less than 5, so we score 100 bonus points. We return the total score plus 100. Otherwise, we just go ahead and return the score. Let's go ahead and test this out here. Console.log score throws. Let's do an array 1, 5, and 11 from the Kata instructions here. Let's go ahead and test this out here. Throwing darts. And we have 15 points here. Now, 15, 20, 30. and we get no points from that. How about 1, 2, 3, and 4? Radii all less than 5 here. Expect to see 140, and we do in fact get 140. Let's go ahead and punch this into Codewars to see what this looks like. Let's go ahead and run the tests. And we are good. Not really much to say about this Kata solution either, but I was looking through some of the other Kata solutions and I ran across something interesting. Something that took me back to the early days of programming with Visual Basic 6.0. And that is that JavaScript actually has a with statement. To use it, you include the expression inside parentheses after the with keyword, and then within the scope of that with statement, within the curly braces, if you elect to use them, JavaScript will automatically include that expression inside of the scope chain of that with block. So, for example, let's say you set the math object as the expression here. Within the block of that with statement, JavaScript automatically includes the math object in the scope chain inside that with statement. So, for example, instead of math.floor, you would just use floor, and that would work the same way as math.floor. Now, it is generally not recommended for you to use the with statement here, and it is actually forbidden in strict mode in ECMAScript version 5 and higher. So I would generally not recommend you use the with statement. I will be including a link to the documentation of the with statement over on MDN in the description box below. In a previous episode of Versus Codewars, we dealt with a kata where we had to add two square matrices together. Here, we are multiplying two square matrices together. Given two two-dimensional arrays representing square matrices, we will assume that the two matrices are of the same dimensions. The goal of this kata is to multiply those matrices together. For example, this one here. Matrix A is 1, 2, 3, 2. Matrix B is 3, 2, 1, 1. And the product of multiplying these matrices is 5, 4, 11, 8. Let me call your attention to the kata instructions here. We're going to read from some of these here. How to multiply two square matrices. We are given two matrices, A and B, of size 2 by 2, for example. Matrix C, the solution that will be returned from this kata solution here, will be equal to the product of A and B. To fill in cell 0, 0 of the solution matrix, we need to compute the following. A cell 0, 0 times B cell 0, 0 plus A cell 0, 1 plus B cell 1, 0. More generally speaking, to fill in cell NM of matrix C, the solution matrix, we need to multiply first the elements of the nth row of matrix A by the elements of the nth column of matrix B, and then add those products together. This will give us the value for cell Mn of matrix C, the solution matrix here. Let me call your attention to this right here in the kata instructions here. First we calculate the solution matrix C, cell 0, 0. We take A cell 0, 0 times B cell 0, 0 plus A cell 0, 1 times B cell 1, 0. In the case of our example here, that would be 1 times 3 plus 2 times 1, and that would give us 5. To calculate C cell 0, 1, we take A cell 0, 0 times B cell 0, 1 plus A cell 0, 1 times B cell 1, 1. That would be 1 times 2 plus 2 times 1. That would give us 4. To calculate C cell 1, 0, we take A cell 1, 0 times B cell 0, 0 plus A cell 1, 1 times B cell 1, 0. And that would be 3 times 3 plus 2 times 1. That would give us 11. And finally, we calculate cell C1, 1 by taking A cell 1, 0 times B cell 0, 1 plus A cell 1, 1 times B cell 1, 1. And that would be 3 times 2 plus 2 times 1. That would give us 8. I'm going to link this article on Wikipedia on matrix multiplication in the description box below. Alright, let's go ahead and give this a try here. As you see, I've got this example right here in our console.log here. And we're going to use this to test out our solution here on the local level. Alright, first let's go ahead and generate the result array here. And we're going to do that by doing const result equals new array. Now, given that the two matrices are going to be of the same exact dimensions, it'll be safe for us to do first.length here for the length of the subarrays of our matrix and the length of our matrix itself. So we'll do const result equals new array, first.length for the length of this array, and then we're going to fill that with another new arrays with that same size. And we're going to fill these subarrays with 0. That is how we are going to create our blank matrix here. I'm going to go ahead and make this a little more readable here. Alright. This result matrix is going to be what's returned. Let's go ahead and test that out thus far. Node matrix multiplication, and we do have our blank matrix generated here. Alright. Now to the heavy lifting of this kata here. I think what we'll go ahead and do, we might need at least 2 for loops, maybe 3. I think we'll do for I equals 0, I is less than result.length plus I. And then we'll have our nested for loop here for let j equals 0, j is less than result.length. These are square arrays. They'll have the same exact dimensions here, so this probably shouldn't be an issue. Plus j. Then what I think we need to do, we might need a third for loop here. And I think that is exactly what we will do. For let k equals 0, k is less than result.length plus k. Then what we'll do is result and I and j. Result cell ij plus equals oh, wait a minute. Oh, right, I forgot about that before. We need to... For subarray of result subarray dot equals new array result dot length dot fill 0. Yeah, let's try that. Assignment a constant variable. This needs to be a let now. Whoop. That actually needs to be a let here. Let's try that again. Cannot read property 0 of undefined. First dot length. Not result. Still cannot read property 0 of undefined. Alright, we'll have to do this another way here. For let I equals 0, I is less than results dot length plus I result at I equals new array first dot length. Again, this has to, yeah, that fill 0. Let's try that. And yep, we do get the matrix we wanted here. We ran into that bug again where we were initializing our subarrays here. The subarrays would be initialized to the same exact array, actually pointing to the same exact array, thus resulting in that issue we were having here. Oh, alright. I think we got it. Let's go ahead and get rid of this console.log here. And we have our solution matrix 5, 4, 11, and 8. Alright, how about... yeah, how about we punch this into Codewars to see what this looks like here. Run this lone test here. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my right here, particularly the very first line of this Kata solution here. Assuming two matrices of the same exact dimensions, here is how you create a new blank matrix for your matrix multiplication. First, you run the first matrix through the map method. Keep in mind, each of these matrices are arrays of subarrays. Now, in this map method's predicate function here, you run the current subarray also through the map method. In that innermost map method's predicate function here, for each element, you go ahead and map that to 0. In so doing, you should have a new blank matrix, an array of unique subarrays with each element set to 0. This should help you avoid the issue of multiple objects pointing to the same subarray, which was the issue I had initially run into when I was working with newArray.fill. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and would like to share your authored katas with me, drop links to those katas in the comments section below, and you might see me tackle those katas in a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.